All right, so we have two more pictures to look at for our position function and try to make some observations about position, velocity, and acceleration, and then speeding up or slowing down. Position is always time units, like feet, like seconds, like feet, and distance units, like feet, for an example. All right, so first, when I look at this curve, I notice that this function, the position function, is increasing. If this was my money, I would be happy with it. Position is increasing. All right. If position is increasing, its rate of change is positive. We have a special name for the rate of change of position, a special name for the derivative of position, and that is velocity. And you could have seen that velocity is positive geometrically. Notice that all these slopes are positive. Slopes of tangents. Right? Now, what about velocity? Is velocity increasing or decreasing over time here? To get a sense of that, let's just estimate little velocities. Let's just estimate little slopes of tangent lines along this curve. So maybe right here, you're going, my slope is up 2 to the right 1, say. My speed is 2 feet per second, and I am traveling up. Sorry for stuttering. Maybe here my slope is about 1. I'm going 1 foot per second, and I'm traveling up. And then maybe here, I don't know, a half. The velocities going from 2 to 1 to a half, over time, those are getting smaller. Velocity is decreasing. And again, I think it was helpful to say decreasing slopes. Two, then 1, then a half. Okay, so if velocity is decreasing, then its rate of change must be negative. We have a special word for the rate of change of velocity, for the derivative of velocity, and that's acceleration. So acceleration is negative. And you could have seen this geometrically. Notice that my position function is concave down. If water rained on it, it would slough off. My position is concave down. Now, what about speeding up or slowing down? Speed is the absolute value of velocity, and all these velocities are already positive. So when I take the absolute value, that doesn't change anything. And so if I look at these speeds, 2 feet per second, 1 feet per second, a half a foot per second, I can see that that particle or object is slowing down. Slowing down. Absolute value of 2, absolute value 1. Absolute value of a half. Right? These are decreasing numbers. Now I want to look at one other example where we're going to see slowing down, and that's with this curve right here. Here is my position function. When I look at it, I would say that position is decreasing. If this were my money, I would not be happy. Therefore, its rate of change is negative. We have a special name for the rate of change of position for the derivative of position, and that's velocity. And you can see this geometrically, all these slopes are negative. Slopes of tangent lines. Now, how would I describe velocity over time? Well, to do that, I want to look at and just do a case by case and estimate these slopes. Maybe right here, we have a slope of about -2. Then maybe a slope of about -1, and then maybe a slope of about -0.5. Those numbers over time are increasing. You're in debt $2, then you're in debt $1, then you're in debt half a dollar. Oh yeah, I'm going in the right direction. Velocity is increasing. Increasing slopes. -2, -1, -0.5. So if velocity is increasing, then its rate of change must be positive. The derivative of velocity must be positive. Oh, we have a special name for that, and that's acceleration. And I can see that acceleration is positive here geometrically because my position function is concave up. If it rained on this shape, water would stay on it. Concave up. All right. Now what about speed? Speed is the absolute value of velocity. So if I took the absolute value of all these numbers, I would be making them positive. So I'd be going 2 feet per second, then 1 foot per second, then 1/2 foot per second. I am slowing down. All right. My eraser's not picking up. We are slowing down. So now, before we go to the next video, which is a conclusion of these last two, I want you to look at each picture and think about position and velocity. What needs to be the case to have slowing down? Here's one picture, and here's another. See you in a second for the conclusion.